Type of process control log feedback feedforward plus feedback ratio cascade split range.
Feedback control, process, heating tank CSTH, 2 equals F, M, T, Q, controlled variable, 2. Manipulating variable, Q.
A feedback loop measures a process variable and sends the measurement to a controller for comparison to set point. If the process variable is not at set point, control action is taken to return the process variable to set point. This control scheme does not take into consideration any of the other variables in the process. Advantages: 1. One of the simplest process control schemes. 2. It is commonly used in the process control industry. 3. It is that directly controls the desired process variable. Disadvantage: the disadvantage of feedback loops is that it takes some time in order that the controlled variable reaches the set point.
Example 1. Consider the liquid level tank shown below. Draw a feedback control loop to control the liquid level inside the tank, H. The control loop should contain the following.
Solution.
Homework 1. Consider the heating tank system below. Construct 2 feedback control loops on the system according to the following description.
Feedforward control. Feedforward loop is a control system that anticipates load disturbances and controls them before they can impact the process variable. For feedforward control to work, the user must have a mathematical understanding of how the manipulated variables will impact the process variable.
An advantage of feedforward control is that error is prevented, rather than corrected. Feedforward scheme is better than feedback control scheme in that it takes no time to manipulate the controlled variable when the system is subjected to a disturbance. The difficulty that face the feedforward loop is that it should take into account all the possible load disturbances in a system, but this is either difficult or costly.
Example 2. Consider the liquid level tank shown below. Draw a feedforward control loop to control the liquid level inside the tank, H. Knowing that H equals F, G, the control loop should contain the following.
Solution: H equals F, G.
Example 3. The diagram below shows pH adjustment. We want to keep the solution in the tank minus 100 torkas at pH equals 7. The pH of the inlet solution is 5. The adjustment is carried out by addition base NaOH. As shown in diagram beside, pH 2 equals F, F1, F2.
Solution.
Feedback loop.
Feedforward plus feedback control. It is a combined system which consists of 2 loops, feedforward and feedback loops. It is used when the controlled variable is function of many variables, so it is difficult to take account for every possible load disturbance. Feedforward is used for the load disturbance which has great effect on controlled variable. Feedback loop is used for controlled variable. Controller with summing functions are used in these combined systems to total the input from both the feedforward loop and the feedback loop, and send a unified signal to the final control element. Example 4. Consider the heating vessel below. The temperature of the outlet stream T3 is function of many variables. T3 equals F, M1, M2, Q, T1, T2. Inlet flow rate M1 is more effective on the controlled variable T3. Use feedforward pulse feedback loop to control the temperature of outlet stream T3.
Solution. Another solution.
Homework 2. 2 liquid level tanks are connected in series as shown in Fig. Beside, the liquid level in the second tank H2 is to be controlled. H2 equals F, Co, Q3, Q4.
Ratio control.
Ratio control is used to ensure that 2 or more flows are kept at the same ratio even if the flows are changing. Suppose that the required ratio A, B equals 1/2. The function of Fy is to multiply the output of Ft by the required ratio A, B. The result is A. This result is used as the set point to the controller Fc. Ratio control is applied in the following cases. 1. Blending 2 or more flows to produce a mixture with specified composition. 2. Blending 2 or more flows to produce a mixture with specified physical properties. 3. Maintaining correct air and fuel mixture to combustion. If the physical characteristic of the mixed flow is measured, a PID controller can be used to manipulate the ratio value. For example, a measurement of the density, gasoline octane rating, color, or other characteristic could be used to control that characteristic by manipulating the ratio. Example 5. Use ratio control loop to control the flow of product, P, and the flow of the reflex, R, back outlet from the overhead drum of a distillation column. The ratio R, P is fixed.
Solution. Suppose we have three streams A, B and C as shown in figure below. The ratio of these streams are A, B, C equals 1, 2, 10. Draw a control loop to adjust the mixed stream at the given ratio. Ratio control for three streams.
Use the ratio control loop to adjust the ratio of fuel that inlet to the furnace as shown in figure below. Homework 3.
Cascade control.
Cascade control consists of two loops, primary loop and secondary loop. Primary loop is constructed on the variable to be controlled, while the secondary loop is constructed on the manipulating variable. Consider the shell and tube heat exchanger in Fig. Beside, suppose we want to control the outlet temperature T2 at a certain value by manipulating variable μ using cascade control. Requirements for cascade control. Secondary loop process dynamics must be at least 4 times as fast as primary loop process dynamics. Secondary loop must have influence over the primary loop. Secondary loop must be measured and controllable.
Example 6. Use cascade loop to control the level of the liquid inside the tank in figure below. Knowing that H equals F, Q1, Q2, use Q2 as manipulating variable. Repeat the solution if we use feedback loop only.
Solution: cascade control loop.
Feedback control loop.
Homework 3. Figure below shows a jacketed reactor which carries out exothermic reaction. We want to control the reaction temperature T. The manipulating variable is the flow rate of the cooling water to the jacket, M.
Split range control. Split control loop is a very common control scheme in which the output of a controller is split to 2 or more of control valves. In this case, one of the control valve is chosen normally closed and the other is chosen normally open. For example, figure below, controller output 0%, valve A fully open and valve B fully closed. Controller output 25%, valve A is 75% open and valve B is 25% open. Controller output 50%, valve A is 50% open and valve B is 50% open. Controller output 75%, valve A is 25% open and valve B is 75% open. Controller output 100%, valve A is fully closed and valve B is fully open.
Example 7. The diagram below shows pH adjustment. We want to keep the solution in the tank minus 100 takas at pH equals 6. Use split range control loop to adjust the value of pH in the tank at 6 with the aid of the acid and base feeding tanks.
Solution. Homework 4. Use split range control loop to control the pressure inside the overhead accumulator, shown below. When the pressure exceeds the desired value, the line to flare will open so the outlet stream is divided into 2 streams, one to flare and the other to process unit.
Reward: 2 marks. Figure below shows a reactor for detergent production. The inlet liquids are in the ratio of A, B, C equals 1, 320. Construct a control system that consists of different loops to control the following output variables. 1. The liquid level inside the reactor. H. 2. The temperature, T, of the reaction mixture. 3. Keep the ratio of inlet feeds constant.